there's a repeated factor like this, so r divided by irreducible raised to third power. Bezout's identity allowed to split those power form because they don't have common factor. Now once you enter this power form, let's say p is a degree 2, then what is the degree of a denominator is degree 6, right? P is quadratic, raised to third power, degree 6. So r is usually degree 5 or less, right? Just like that advanced problem. Then this long division allows us, you can actually write it like this, p and p squared and p to the third. More importantly, r is potentially degree 5, but you can keep that each of the numerator degree less than p. So if p was quadratic, in that case it's all linear, 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 just like AP problem, right? So that's the purpose of it. Here, have a large numerator degree, you can knock that down to small numerator degree with this various powers. And they're all unique and all that part. All right, that's the partial decomposition. So here's one repeated factor. I'm going to show you the first example and how to approach this one. But let's first practice on the shapes. I think I wrote it down there. So this is an example of repeated factor. Repeated irreducible factors. We want to look at it that way. So do you see that repeated irreducible factor? X minus 1 repeated 3 times down there, right? So let's practice on, I know some of you already know this one, shape. Use that theorem to get down to the shape of the decomposition. All right? So what is that shape? So what is the degree in the numerator? Degree 2, right? Down here, degree 3 altogether. So they wanted to go like this, where we can write down how was the second part of the theorem look like. Let me show you that theorem again. This is long division theorem. P is a linear, Q is a degree 2. And they're claiming that you can write down the power all the way up to the whatever the maximum power, keeping the numerator degree less than the denominator of the irreducible factor without the exponent, right? So what is the case here? So the first x minus 1 squared, x minus 1 cubed, right? That's what they're saying. You can be split it further like this. How about numerator? You can keep it really small. Degree less than x minus 1, the irreducible factor alone. So it's A, there's a B, and C everywhere. This is not bx plus c and dx plus e. They're all degree less than the main irreducible factor, which is 1, so less than this constant. Does that make sense? Okay. From here is the same problem of method 1, comparing the coefficient. 3 by 3 equations, right? So we don't do that. So next method is a specialization. You do that at home. I'm not going to do it here. Specialization. So left-hand side x squared, correct? Numerator part. So how do you combine the denominator? What is multiplied to a? X minus 1, how many power? Square is enough. Third power is the largest one you have to reach. If you multiply square squared, the denominator reaches a cube, right? So a square is the minimum power. You have to multiply the denominator. Any question about this choice of square? Is that okay? How about b? To reach the maximum power, to combine it to a common denominator, you only need one copy, x minus 1. So here, x minus 1. Correct? C already has a full copy there, so you don't have to multiply anything. That is x squared. Supposed to be x squared, right? Now you expand and compare the coefficient, and that's how this one goes. Well, inspection tells you this is the only part that has x squared coming out, right? Correct? That's the x squared. So a must be 1. There's always little thing you can do to reduce the amount of calculation you do. However, let's specialize it. How do you specialize it? X equals 1 is the only thing that you can do here, right? Nicely. So what is C? Left-hand side is 1 there. And C is 1, is that correct? 1, 1, 1. Right. Next specialization, B and C, no problem. I'm going to stick in 0. I'm going to stick in -1. You will get to the B and C quickly, correct? Fair enough? So B and C. Let's plug in 0 there. What do you get? Left-hand side is 0. Right-hand side is A times -b, and C is 1. That's one equation you get. How about x equals -1? Then here's a -1 is +1. -1 is a 4a, correct? -1 is -2b plus 1 again. So you solve this equation to get a and b. Good? So third method, I think I'm doing this first time, differentiation. Seems like differentiation is pretty simple in here because x minus 1 is not multiplied by x plus 1 or other quadratic factor. It's just one linear factor there. So it seems differentiation is effective. So if you differentiate this one time, what do you get? 2x, right? Right hand side? 2a x minus 1. Chain rule has no effect here because derivative of x minus 1 is 1. Here, b. Now you have a new equation. It's not redundant. It's very different. Now if you specialize x equals 1 here, then you get something out here. X equals 1. What do you get on left hand side? 2. X equals 1 is 0. X equals 2. B is 2. How nice, right? So b is 2. We got that b. We got that c. How do you get a? The best way is that you plug in 0 here. So x equals 0. Then it's a 0. 2a times 0 -1. And what is b? Is a 2, right? So is a supposed to be 1? We already knew that a was 1 at the beginning. So a is 1. Yes?
Are we allowed to combine methods like that? Like finding a with that method
Yeah.
and finding b and c with the other method?
Yeah, I would actually do that. I would juggle anything that speed up, calculations. Just do it correctly. And that's if you combine it. If you don't write it down, there's a good chance that you mixed up something. And so if you write it down, usually it's okay. So what is the answer? Your final answer: 1 x minus 1. B, where's b? 2 divided by x minus 1 squared. What is c? 1 divided by x minus 1 cubed. Each individual term, you know how to integrate, right? So we're doing the whole thing to integrate this guy and this log integral and x minus 1 to the -1 power, x minus 2 -2 power. It's all integrable. Make sense? All right. So here's our second problem. So here's your challenge to combine specialization and derivative or something like that. But I encourage you to do the derivative. Try it, see what happens. But first we're going to work on the shape together. And this requires a little bit of explanation. That will do that much, but I will leave the rest as an exercise. And we can, while we're doing this, you're welcome to interrupt in doing any questions. Let's see. This one, you see how many irreducible factors? How many distinct irreducible factors? 2 is correct. X plus 1 and x minus 1. And x minus 1 is repeated, right? Okay. So when you apply two things, Bezout's identity and this long division. Let's do Bezout's identity first. If you apply Bezout's identity, it can be split into 3 pieces, and that Bezout's identity require no common factor, right? So x minus 1 and all third power must be clogged together. If they split, then they introduce a common factor of the two parts. So x minus 1 can't go anywhere. You have to stick there. X plus 1 is distinct. So would you agree that Bezout's identity guarantees that it must be split like this? And I'm going to call that one must be degree less than this a, and this one here b tilde x plus c tilde, because it's intermediate stage and we're going to get to the plain letter later. Does that make sense? All right. So does Bezout's identity make sense? I think I did it wrong. This is degree 3, and what is it supposed to be? Degree 2. So it's degree 2 and cx plus d tilde. That's the correct Bezout's identity application. You can't do anything else because there's only 2 factors involved. Does that make sense? No common factors. All right. Then what do we do about this x minus 1 cubed? Now it's a long division. You can go down to x minus 1 squared, x minus 1 cubed, right? Correct? Now this x minus 1 degree 1 less, it must be constant. How about over here? It's a degree 2 down there, right? What should be the degree over here? Still degree 0. That is the long division. Still degree 0 is a C. Pay attention to that. Let me show you that it's in red color here. When you decompose it like this, you can keep the numerator degree very small, not degree of a p to the second, p to the third, always less than degree p of this small factor. Therefore, this x minus 1 is here is a plus d. Okay, that's the shape of decomposition. All you have to figure out now is what are those a, b, c, d. You're entering 4x4 equation, right? Very reluctant to solve that 4x4 equation, right? So specialization is good here. So from here is your exercise. Number 2, use the specialization. Just checking on the number of exercise there. All right, I started with x equals -1. So that makes the entire thing 0 here. That gives a equals -1/8. Anybody agree with my value, a being -1/8? Now I'm doing x equals 1, that first 3 times go, and the d being 1/2. Okay, everything is 0. Plug in 1, 2 times d, x squared is still 1, so d is 1/2. Correct? Now, how about the b and c? Now you can specialize. There's only b and c, 2 values, right? So, hey, 2 values not a problem. You can plug in x equals 0 and x equals 2, that you have a new something. So you come up with a 2x2 equation. But I differentiated, knowing that there is a repeated factor. Differentiation maybe work nice. So I did derivative, the 2x. This one is 3 times a minus x squared. Product here. So you have to use the product rule. All right? So differentiate that one. Oh, this one first, so x minus 1 squared. The second one differentiated here, 2 times x minus 1. Here's the differentiate that one, x minus 1. Differentiate this one, x plus 1. And plus, that's derivative is just d. All right? So this is a little downside. If there's a different product rule, when you derivative, it comes out like that. But still, lots of parts are 0. That's a good part. When you actually plug in x equals 1 now after you differentiate, here's a 2, that one becomes 0, that one becomes 0, that one becomes 0. Still lots of parts are 0. So it ended up at giving you a pretty simple equation like this. 2c, this is 0, and that's 0, and 2 and 0 and it's 1, so it's a 2d and plus d. So if you solve it, I get c being 3/4. Does anyone else have a c being 3/4? Agree with that? Very good. And the last one, I looked at this derivative equation in here. I just plugged in x equals 0 there. Maybe plugging x equals 0 is a simpler, the original equation. However we do it, should have gotten the same value of b 1/8 there. All right? So put that all 4 numbers there and integrate, and that's what this problem's about. Does that make sense? Question? All right. So that's one repeated factor being in there. We didn't actually do comparing the coefficient, but you can always do that and came up with that 4x4 equation in an earlier case. And if you specialize, and you can probably do it a little bit faster. All right. So this is a